This is PreCalculus 12, Chapter 6.2. We're going to be looking at angles in standard position and arc length. Radian is the ratio between the arc length and the radius. So here we have an arc length, and here we have the radius. So we're taking the arc length and dividing it by the radius. And this is another way to measure angle. Okay, just like the unit circle is convenient, we like to think of the unit circle here as well and having r as 1. If we have r as 1, then the arc length is your measure of radian. And we like to abbreviate arc length with the letter S. And how do we come up with the arc length? Well, the circumference is 2 pi r. And if r is 1, and when we take the circumference and divide it by the radius, we get 2 pi. So 2 pi is equivalent to 360 degrees. Now we have certain properties when we're using radians. The angle is S divided by R, similar to what we have here, C divided by R. That's the whole circle, but if we take part of the circle, it's S divided by R. S, the arc length, is a length. And because we have length, we need to use absolute value. And it will depend on context for word problems. So if they say displacement instead of length, you would have to remove the absolute value sign for displacement. And r is equal to the arc length divided by the angle. Okay, and we have the formulas in degrees if you like to use degrees, but try to get used to radians. Now, converting between degrees and radians, well, we use this equivalent, but what we'll do is simplify it. So it's 360 degrees divided by 2 pi radians. The radians cancel out. And we can divide 2. So we have 180 over pi. That's the conversion factor. If we want to go from degrees to radians, we have 2 pi radians over 360 degrees times our degrees. So the degrees cancel out, and 2 cancels out, and we have 180. So we're left with pi over 180, and it's radians. And here we have degrees. Okay, let's try some examples. 30 degrees, we want to convert it to radians, so we use this formula. So we have 30 degrees times pi radians over 180 degrees. We need degrees here. And we get pi over 6 radians. 18 divided by 3 is 6. And 270 degrees times pi over 180 degrees radians. Degrees cancel out. 90 is our common factor, so 3 and 2. So we get 3 pi over 2 radians. Negative 135 degrees, pi over 180 degrees, radians. Degrees cancel out. Common factor is 45. This is negative 3. This is 4. And we get negative 3 pi over 4 radians. 720 pi over 180. Common factor is 180. This is 4. And rads. So we get 4 pi radians. So as I mentioned before, it's okay to convert at the beginning, but it's best to get in the habit of thinking in radians. Here are some problems where we need to compute the arc length. It's a measure of length. So it means we need units. Okay, so again, we'll convert at the start. 85 degrees times pi over 180 degrees radians. So when you're starting off, put the degrees so you'll know that you've got the right formula, because the degrees should cancel out. This reduces to 17 pi over 36 radians. Now we use the formula S equals absolute value of R theta, absolute value of 7.4 times 17 pi over 36. And this is approximately 10.978 units. Decimal value. So answer with decimals. If not specified. Let's look at the next example. Theta equals 140 degrees, pi over 180 degrees, radians equals 14 over 18, reduces to 7 pi over 9 radians. S equals the absolute value of R theta equals absolute value of 5, 7 pi over 9. So this is 35 pi over 9 units. Exact value. So answer in terms of pi. So that means we don't convert the pi to a decimal value. One more example. There's no degrees here, so there's no conversion necessary. We just go straight into the formula. S equals absolute value of R theta equals absolute value of 7 times 3 pi. That's 21 pi units. Okay, definition of principal angle. You've been given the definition for degrees. Here's one for radians. It's the smallest positive coterminal angle. So that means theta must be between 0 and 2 pi. Again, it's convenient because we can determine what quadrant an angle is in. We start at 0, go to pi over 2, go to pi, go to 3 pi over 2, and back to 2 pi. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, find the principal angle of 730 degrees. You can do this in steps. And then you need to do 370 minus 360. That equals 10 degrees. Or you can just see it right away and say 730 degrees minus 720 degrees equals 10 degrees. This time we have to add 360 degrees. Here we're in radians. We can just subtract even pi's. So we have 5 pi minus 4 pi. And that's just pi. Here we have to add 2 pi. And when you have a fraction like this, you want to just convert this to a common denominator. So here's some useful conversions as well. 1 revolution equals 2 pi radians. 1 revolution equals 360 degrees. And you already had this before, 2 pi radians equals 360 degrees. And when you're converting, use this in fraction form. That way you can cancel properly. So what I mean is you would use 1 rev over 2 pi radians and then cancel out as needed. Or you flip it around. You can use it however you like. 1 rev over 2 pi or 2 pi over 1 rev. Same with these. And that completes this lesson.